Good morning. Myself Dr. Jagannath Samanta and my colleague Mr. Tapan Kumar Maiti. Our project topic design and development of IoT based smart devices to measure air and soil condition in agriculture field. So this setup we have ready to demonstrate the final completion of our R&D scheme project that is funded by IEI. Thank you to financing us to develop this project. So our project will be demonstrated by my two students. One is Ayush Roy and another Oishik Das. They will demonstrate the whole project.
My name is Ayush Rai, and we are here to demonstrate our project named Design and Development of IoT-based Smart Devices to measure air and soil condition in agricultural fields.
Good morning everyone, my name is Oishik Das and we are here to demonstrate the project that we have made with the financial aid grant scheme of Indian Institute of Engineers India. So in this project, basically what we are doing is we are trying to semi-automate the agricultural processes. So we are using the Internet of Things that depicts actual articles gathering with sensors and handling skills and programming and different advancement in that interface. That is, Internet of Things is currently the one of the best technologies to integrate with all other technologies, which provides a wonderful support to many technologies, and we are implementing the same technology in the Internet of in our project, that is automating and smart measurement of agricultural parameters. So this is the objective of our project. In this project we are doing actually farming is actually one of the most important things that the mankind needs right now, and due to the global warming and various changes, the agricultural processes are readily affected. So with the help of our project we can actually semi-automate the agricultural processes, and that will also help us reduce the labor demand, and the production will be high so that everyone can have good agricultural output and we can feed every person in this planet. So this is the Internet of Things. The current definition is Internet of Things IoT describes the network of physical objects, things that are embedded with sensors, software and other technologies to connect and exchange data with other devices and systems over the internet. These devices range from ordinary objects to sophisticated industrial tools. These are the three-layered IoT architecture that IoT generally works in, that is perception layer, network layer and application layer. And we have to consider various aspects, and these are the various applications of IoT. As I mentioned earlier, that IoT is one of the best technologies to provide support to any technology that currently works in our world. In this project we are actually using IoT in the smart agricultural domain to automate the agricultural processes, and this is the main block diagram that we are using. Currently we can see that we are using Raspberry Pi as our central node, and we are giving a power supply through our laptop, and there are various sensors that we are using such as temperature, humidity, moisture, light, sound and camera. The output of this device is connected through via relay to the pump that we can turn on and off whenever we need with respect to the soil moisture content. And for the use of IoT we are using a cloud service platform, that is Blink cloud service provider, that can be connected with various smart devices such as this laptop and this mobile phone, that we can get notification and we can control the processes automatically sitting remotely anywhere in the world. And this is the flowchart. This is how our project actually works. And like microcontroller gets sensors take all the inputs from the parameters such as moisture, temperature, humidity, light, CO2 gas value from its surroundings, and it sends the things to the central node, that is the microcontroller that we are using here is the Raspberry Pi. The microcontroller has an inbuilt Wi-Fi module which can be connected to the internet via the cloud platform, and that cloud platform can be controlled and analyze the data with the help of smart devices. We can also send output data and our desired responses to the back to the node, and we can actually control the pump that we are using here, and we can control the water pump through the smart devices, and all the other devices are connected with the help of IoT and our Blink cloud service provide app.
Now coming to the circuit diagram of the input sensors. For example, here we can see that the moisture sensor DHT11 we are using to measure the temperature and humidity. Then we are using the mic sensor to detect noise for pests or any other harmful insects that may invade the field to destroy the crops. Here we are using the LDR to measure the light intensity, and this is a CO2 gas sensor or MQ135 sensor that we are using to measure the CO2 levels in the atmosphere. This is our soil moisture sensor that we are using to measure the soil levels, moisture level in the soil. And this is our Raspberry Pi camera module that will actually do a kind of monitoring stuff like whether there are pests or any animals have invaded our field or not. For example, this is the camera module that we have implemented. This is the DHT11 sensor. This is the actually A to ADC or analog to digital converter that is actually converting the analog values taken from different sensors like gas sensor, sound sensor, and the moisture sensor, and it is converting it to a digital value so that Raspberry Pi can actually process it and send it to the cloud platform. And here we are implementing analog LDR sensor. This is our motor driver that actually drives the pump, and this is the power supply for the motor driver. Now these are the actual device services we have used. For example, the Raspberry Pi Model B, which is actually the brain of our entire IoT system here. It is actually a microcomputer. Then our DHT11 temperature and humidity sensor, our KY038 sound sensor, soil moisture sensor, gas sensor, the camera module, LDR, and our services that actually using like Blink Cloud and mobile app services. Here we can actually see the mobile app service that is actually running. This is our proposed model, as we can see here.
And here also
We can see our proposed model. This is our actually the proposed model that we have implemented.
using various sensors we have implemented this proposed model.
And this is our output figure, like a web interface where we are actually getting the output, and where the user can monitor. They can turn on the pump and camera according to their need. If the moisture is low, they can turn on the pump, and if they want to monitor the field, they can turn on the camera to take a picture and see in a mobile. This is the mobile interface that they will be seeing in the small smart devices. And now coming to the conclusion,
we are seeing that the agricultural processes are very important, and we need to actually maximize the agricultural output in our day-to-day lives to improve this quality of standard. And in a developing country like India, we need to implement as much as technology as possible to increase the agricultural output, as our population mainly depends on agriculture till now. And if that can be implemented, that overall economic growth can be boosted widely. So in use of technology such as Internet of Things can actually help us gain that vision, and to actually help farmers, those who are at the lowest income group in our country. That will also help them increase their income. So we have used in our project, that is what we have demonstrated. We have tried to demonstrate that it is possible with the use of various sensors and small micro devices such as the Raspberry Pi module, which is very helpful, and it actually works in real life also. And we can see here, we can measure the moisture content, we can measure the light, sound, etc. in real life also, and we can monitor the data in real time. That is very helpful, and that will also help to monitor and measure the agricultural parameter. And we can analyze the data with the help of Blink Cloud Service app, and that will also help to make future processes very helpful. So we are going to demonstrate how our current project works. So this is the code that is we have written in the coding language named Python, and we are using Raspberry Pi to code the various sensors using the Python language. And currently we are going to run the code which will help us monitor and measure the agricultural parameters. So this here it is connecting to the Blink Cloud Service provider, and in the serial monitor we are getting various values such as temperature, light, CO2, sound raw, moisture and moisture value, etc.
this is actually we are transmitting the data at an interval of 2 seconds, because Blink says that if we transmit data bulkly, then it may disconnect our services. So we are actually sending the data at an interval of 2 seconds. And as we can see here that our mobile app interface is showing the data that is being monitored at the moment as it is changing. The moisture is there, light is also detecting. We can also show our web interface. This is actually the web interface. Here we have button for camera to turn on off the camera, the pump to turn off. Scale turn. These are the different parameters.
That is temperature. Here is the temperature. We can monitor the temperature here. We can monitor the humidity. We can monitor the light intensity, we can monitor the CO2 value, we can monitor the noise that is used to detect the pests in our field, we can detect the moisture content of the soil. We can also turn on and off the camera to take pictures to get the monitoring perfectly. And this LED actually shows us that whether the soil moisture content is high or low. It will be red if it's high and it will be green if it's and we can turn on and off the pump with the help of this button. So currently we are going to demonstrate the light intensity. As we can see, if there is the dark condition, in normal condition, the light intensity is 8342 lux. But when the light intensity increases, that is we are using mobile flashlight to increase the light intensity, we can actually see the light intensity came down to 1055. So that actually demonstrates the light intensity. We can measure the light intensity in the agricultural parameters. The second thing we are going to measure is the moisture content. Currently the moisture is at 61.55, and we can see here we have put the moisture sensor in the down the water, and if we take this out, the moisture sensor actually the LED will blink red, and we are getting moisture value to 14.86,
And we are getting a notification.
and we are getting a notification in our smart device that moisture is low, turn on the pump. Now we will turn on and off the pump remotely, which will demonstrate how we can remotely control the desired output of our smart device. So here from the cloud interface, that is web app, we can turn actually on the pump, and we can see the desired response over here. So we are turning on the pump
now.
and we can see our pump
We've also got a
turns
notification.
on, and we also got a notification here that we have turned on the pump in our smart device. And now we have turned off the pump, and the pump has been turned off.
And now for monitoring purpose, we can also use our camera module that we have attached with the Raspberry Pi. Here this is the camera module, and we can turn on the camera remotely. Like if we turn on the camera now, we will get a notification when the photo has been taken. It will take a little bit. Yes, now we are getting a notification that
the picture has been taken.
We can turn off the camera. So I am turning off the camera now.
And like this, we can measure the temperature that is currently present in the environment. We can measure the humidity that is detected automatically. We don't need to interfere in that. And similarly, we can detect the CO2 content of the air, moisture, and the noise level, and the light intensity has been demonstrated. So this was the complete demonstration of our project, and this is how the various sensors work, and we can monitor various agricultural parameters.
Thank you, my student, and thank you once again, Institute of Engineers India, to provide the financial support to develop our project. So thank you once again.